Okay, so I was having some issues getting certain pins to activate from other pins, and I'm going to show you the problems and what I did to eliminate it and get everything to work. I'm sure this is a known issue, but it was something I came across trying to get certain things to turn on and off. It's getting weird stuff going on, and just going to show you what happened here. Okay, so with the first one here, just to give you the example, we got the serial begin communication with the computer. We got pin mode A1 is an input. We have 10 as an output. I have 10 high down here, and I'm just showing the read of A1. So I'm not doing anything to A1, just declaring it an input. That's it. I'm going to show you on the serial monitor what happens here. Alright, so here we have the serial monitor running. This is with the board with A1 open, nothing's plugged into it at all. So now I'm just going to take a pin connector wire with an open end, so nothing connected to it at all. I'm just plugging it into A1. And you can see there it's kind of getting a couple ones and zeros. So that's with nothing connected to it at all. So now I'll just take it out, and we got back zeros, and plug it back in. There's our 1 zeros, and now I'm going to plug the other end into 10, and there's our 1. So we got the high reading from 10. So when the cord is just plugged in like this, we get all these kind of twitchy movements. And there's the zeros with the cord unplugged. So just from plugging the cord in, it was turning my stuff on. Okay, so now I figured instead of the digital read, since it's just a high and a low state and I don't have any play there, I would change it to an analog read and figure out what the play was, and then I could, give myself a little bit of room. So all I did was change that A1 from digital read to analog read. Alright, so now we're showing the analog read of A1 with nothing plugged into it at all. I'm going to do the same thing and just take an open-ended cord and plug it into A1. There we had some jumps a little bit right when it was plugged in, nothing too bad. Now when I touch the end of it, see how we jump up to 1, 2, 3, blah blah blah. It's kind of going all over the place. I let go. Now that was grabbing the end of the open wire. Now I'm just grabbing the insulated part of the wire, and you see we still get some weird stuff going on. And then I will plug the wire into 10, and there's our solid 1, 0, 2, 3 that we're looking for. So this as well just gives some really weird readings, and it was activating for me touching the wire and other weird stuff happening there. So it wasn't until I changed this here to an output that I stopped having the problem. I also put digital right down here, and I did so now with that low, we'll go back to the serial monitor and I'll show you what happens. It's pretty self-explanatory. So here we are back at the serial monitor. We're running A1 at low. We're getting the analog read of A1 here still, and it's a 0. Now we touch the end of the wire. Nothing happens. We unplug the wire. Nothing happens. We plug the wire back in. We're still at 0, so we get no interference there. And then we plug into our high 10, and we get a reading. It's not 1023, but it's something. So it's at least going from 0 here when we unplug it to about 400 or 500 there, under 500, and it's pretty steady. So that gives us a 0, an up, and then makes it much easier to activate things. Okay, so here I've just taken an LED light with a resistor and put it in line from 10 to A1, and I'm getting an analog read. I'm doing high-low from 10 to A1, and I'm getting the analog read of A1. So I'm using that analog read to do stuff, and this is showing you that the analog read of A1 is at 0. When I plug the light in now, it's not the 400 that it was, it's a lot lower, it's 137, 138, but now I get a light on, so now I also would run a switch in line with this. So when I hit the switch, it connects it, and obviously gives me a 138, and when the switch is off, I get a 0, switch on, bing, off, on, with the switch in line with that. And then here's just an example of how I ended up using this. I've used it a couple different ways, but this was how I figured all this out, because I was having a lot of fishy movement with a step motor. I was trying to get a step motor to rotate one way by pressing a button, and then rotate another way by pressing a different button. And I know this could probably be simplified. It might look a little complicated, whatever, but it works here. So all that I did was I have 6 and 7 were my outputs here, so they were running to A4 and A5, which are also outputs, but those were low. So looking down here, I got 6, 7 high, A4, A5 low, and then all I did here was declare pin state A and B, the analog read of A4 and A5, and then I used this is kind of a manipulation of a code to run a stepper motor with the with this stepper library here, and it would rotate the stepper motor one direction for a certain amount of time, for a delay, and then run it the other way, delay, run it the other way. And all I did was put an if statement in here saying that if pin A, which is the analog read of A4, is greater than 100, because I'm running an LED light in line and it was about a 130-ish, which was above 100. Went with 100 just to be safe. So when the LED light and it's not running power at 0, I hit the LED light, it's 130. So then I get above 100 and it rotates the motor one way, so that's pressing one button, and then when I push the other button, it rotates it the other way, and it works pretty well. The motor doesn't move when the buttons aren't being pushed. And that's just an example of how it worked when I would input a different, like a digital read function here to read high or low. I would get some fidgety stuff going on. The motor would just rotate from the pin being plugged in and stuff like that. So that worked out pretty well.